In this video, we will try to learn how to find fiscal policy multiplier from the given national income data and the money supply. The question is like this. The following data is given for an economy, okay? We are being given C is equal to 60 plus 0.75 Y subscript D. C is the consumption function. 0.75 is our marginal propensity to consume. Y subscript D denotes the disposable income. Lump sum tax is being given as 100. Investment is a function of interest rate. That means I is equal to 80 minus 10I, where I is the rate of interest. Government expenditure is 100. Demand for money is given by L is equal to 0.2Y minus 5I. That means demand for money is a function of income and rate of interest. Okay, and real money supply is exogenously given as a 65. We have to find out the value of fiscal policy multiplier. Okay, so the options are 1.23, 1.53, 2.62 or 2.98. Okay, so before we solve or find the fiscal policy multiplier, it will be better if we know how to find the fiscal policy multiplier. Okay, so first we will find out the fiscal policy multiplier. Okay, for that we need the IS equation and LM equation. Okay, so how do we write IS equation? IS equation is being given as Y is equal to A bar upon 1 minus C minus BI upon 1 minus C. This is our IS equation. Okay, if you are wondering how do I derive this, I have explained it in the IS equation ISLM derivation model. I will put a link into the description box and also into the info button. How do I calculate this IS equation? If I try to derive this equation, it will get very lengthy video. Okay, so remember this is the function for IS equation. Okay, and this beta here, sorry, this B shows us responsiveness of income, okay, to change in the rate of interest. Okay, and this is the intercept, and this B upon 1 minus C denotes the slope. Okay, so if I write it like this, let me write it like this. Y is equal to 1 upon 1 minus C. If I write it like this, alpha G. Okay, this is our multiplier, Keynesian multiplier. Okay, minus here I also can write alpha G, okay, into BI, and I forget to write it here, this very A. Okay, so we have A bar also. Okay, so I have just sorted this out, and in place of this 1 upon 1 minus C, I have written it alpha G. Obviously this is our Keynesian multiplier also. Okay, this is our IS equation. And how do we derive the LM equation? As I told you, I will not show it in length how to derive it. I have explained it in an earlier video. I will put the description box the link of that very video. Okay, so let me write it. We know that a demand for money at equilibrium, demand for money. Okay, so let me write it like this. Demand for money should be equal to supply of money. Okay, I don't know how to write it here, so let me write it. Money demand should be equal to money supply. We know that at equilibrium this condition should hold for LM curve. Okay, now demand for money, as you know, demand for money is the positive function of income. Okay, or we can write demand for money has two components. That is, first is the transactionary demand for money, and second one is speculative demand for money. Okay, so these two add up, and this should be equal to our money supply. Okay, now this transactionary demand for money is the positive function of income. Let me write it K times Y minus, and this speculative demand for money is the negative function of rate of interest. Okay, let me write it here. HI, okay, should be equal to money supply. And what is our money supply? Let us denote it by M upon P. Okay, so I'm just trying to derive how do we use the fiscal policy multiplier in this equation. Demand for money should be equal to supply for money. Demand for money has two components: transactionary demand for money, which is a positive function of income, and speculative demand for money, which is the negative function of rate of interest. Okay, and it should be equal to money supply. I repeat, I have explained it in clear words. How do we derive IS and LM equations? Okay, I will not go into the further details because this video will get very lengthy then. Okay, so this is our solving for, let us say we solve it for rate of interest. Okay, so let us solve this for I. So I can write it like this. If I transpose this here, so HI is equal to KY minus M upon P. Okay, or I is equal to transposing this K upon H Y minus we have M upon P. Okay, and we have this 1 upon H. I hope I know how you know it better. How do I derive this? Okay, so we solve this very function for rate of interest. Not now what we need to do, we just need to put this very value of I in this equation, in our IS equation. Okay, so if I put the value of I here, that means our Y will be equal to, let me write it here, Y is equal to, we have alpha g, then we have A bar, okay, minus, then we have alpha g again, okay, we have B. In place of I can write this stuff, that is K upon H Y minus M upon P into 1 upon H. Okay, now let's do some calculation here. So we have alpha g A bar minus, okay, we have alpha g B K upon H Y. So I can write alpha g B K upon H Y, minus to minus is plus. Again we have alpha g B M upon P into 1 upon H. Okay, now taking this Y, okay, so here we have the Y variable, taking this to the LHS, so this will become Y, this is minus, this will become plus. We have alpha g, we have B K upon H Y, and in RHS we are left with alpha g A, okay, plus alpha g this stuff, that is we have B M upon P into 1 upon H. Okay, I hope I am making myself clear. Now taking Y common, we are left with 1 plus alpha g. Okay, so this can be written like this, B upon H K, okay, is equal to alpha g A bar plus alpha g, we have M upon P, and this can be written as B upon H. Okay, B upon H. I hope I am making myself clear. Now what we can do here, so I am here short of space, so let us rub this out. Okay, with very heavy heart I have to rub this out. So if we transpose this term to RHS, it will get multiplied to this term and divided to this term and to this term. Okay, so I can write Y is equal to alpha g A dash upon 1 plus alpha g B upon H K, okay, plus we have alpha g M upon P and B upon H. I hope I have made the calculation right, and this term will get divided to this term also. Okay, so we have 1 plus alpha g B upon H K. I hope I am making myself clear. Now what we need to do, since we need to find the fiscal policy multiplier, Okay, so fiscal policy multiplier shows us change in income with respect to change in government expenditure. Okay, so fiscal policy multiplier shows us change in income with respect to change in government expenditure. Okay, so that means we need to differentiate this very function with respect to g. Do we have this choice variable g? Yes, obviously we have. This a bar is actually our g here. Okay, why this is g? This here we have no, this is sorry, let me write it, let me explain it here. This a day shows us the autonomous things here. Okay, so a bar shows us the autonomous expenditure here. Okay, and here autonomous expenditure is equal to government expenditure. This cannot be the thing here. This is the monitor, this is money supply here. Okay, so this a dash is actually our g here. Okay, that means in place of a dash I can write g. That means we have to take the derivative of this function with respect to, let us write it as this is gamma. Okay, let us gamma. So to find the fiscal multiplier, just differentiate this very function with respect to g. Okay, so the derivative of g is 1. We are left with alpha g, okay, upon 1 plus alpha g b upon h. Okay, this is our fiscal policy multiplier. If you want to find out the monetary uh, policy multiplier, what we call monetary policy multiplier, that means we have to find the change in income with respect to change in money supply. Okay, this will give us the monetary policy multiplier. In this case, derivative of this m upon p will be 1, so we are left with alpha g b upon h whole 1 plus alpha g b upon hk. This will be the monetary policy multiplier, but this is not our headache this time. We need to find out the fiscal policy multiplier. Okay, so this is our fiscal policy multiplier. Now what does this alpha g is? As I have told you, alpha g is equal to 1 upon 1 minus c. That means this is 1 upon 1 minus mpc. Okay, so this is, what is b, h and k? Actually, B, H, and K, I have explained it. Demand for money is being given us. Let me write it here. 0.2y minus 5i. Okay, this is demand for money, and this K here, this K, uh, let me write it here. This K denotes, actually it is 0.25. Okay, so I forget, this is 0.25. Here it is also 0.25. This is our k variable, k coefficient of y. Okay, and this 5 is our h. This is demand for money, which is the positive function of income and negative function of rate of interest. Okay, this k shows us, this k shows us the, what we call the income sensitiveness of demand for money, and this h denotes the interest sensitivity for demand for money. Okay, how much our demand for money changes when there is change in interest rate. This is given by this very h. Here it is 5. How much our income changes if there is change in, sorry, how much our demand for money changes if there is change in the level of income, and this is given by this coefficient 0.25, and it is denoted by k. Okay, and what is our, what was our planned investment function? Here I is equal to 80 minus 10i. Okay, this 10 denotes our, so this is our k and h, this is our b. Okay, so this is our b. So what does this tell us? This is the investment function, which is the negative function of rate of interest. It shows us responsiveness of investment to change in the rate of interest. Simple thing. Okay, so You don't need to do this very stuff. If you can remember this formula, just plug the values here, you can find out the fiscal policy multiplier. Okay, so that means our gamma is equal to del y upon del g will be equal to, what is our alpha? Okay, 1 upon mpc. This is our, here we have 0 0.75, 0 0.75. Okay, so alpha g is equal to, so for that, if we solve this, that is, why do I write? So let me write it here. So our alpha g is equal to 1 upon 1 minus mpc 0 0.75. 1 minus 0 0.75 comes out to be 0 0.25. That means our 1 upon 0 0.25 comes out to be 4. That means our alpha g Keynesian multiplier is 4. Okay, so in place of alpha g I can write 4 divided by 1 plus alpha g is 4. Okay, what is b? B is this, interest sensitiveness of money is denoted by this very 10. So in place of this I can write 10. Okay, so our b is 10. Let me write it here, 10 upon, what is our h? Our h is 5. So let me write it here, 5. What is k? K is 0 0.25. Okay, when you solve this will come out to be 4 upon 1 plus 5 ones are 5 twos are 10, 5 ones are 5 twos are 10, 4 twos are 8. This comes out to be 8 into 0.25. This will come out to be 1.33. Okay, so the correct option should be 1.33, but 1.33 is not the option here, so I will go for 1.23. Okay, though this is not same as I have calculated. If you calculate this step, it will come out to be 1.33. Either all the options are wrong, or you have to go for the most closest one here. Okay, 1.23. I hope I make myself clear in this video. So if you think you are getting confused, it is very simple. First, you need to, rather you can just plug this very formula. Okay, I was just trying to show you how do I derive this very formula. This is our fiscal policy multiplier, this is our monetary policy multiplier. How much income changes when there is change in money supply is given by this. How much our income changes when there is change in the government expenditure. Okay, so this is, so this a bar is here synonymous to our government expenditure. Okay, because we have no other variable in this, we don't have our choice variable, this is money supply. Okay, so we have to see, by fiscal policy multiplier we mean to say change in the level of GDP when there is change in the government expenditure. Okay, so these are the autonomous terms here. This is how do I calculated it. Okay, so if I can repeat, first what you need to do, first you need to find out the IS equation, which is given by y is equal to a upon 1 minus c, okay, minus bi 1 minus c. Okay, so this 1 upon 1 minus c is actually our Keynesian multiplier, and here you can also see that this fiscal policy multiplier is less than the Keynesian multiplier here. Okay, so first you need to find this very equation, then LM equation is formed by y is equal to 1 upon k m upon p plus h upon ki. Okay, if you solve this for I, you will get as I have shown it here. I forgot how did I wrote it here. So solving this for I, you will get something like this. Actually I forgot what I have explained. Okay, so when you solve this for I, then you need to plug this very I is equal to this very thing in this equation. For that, then you solve for the y, and you will get this fiscal policy multiplier, and this is our monetary policy multiplier. Okay, so what did we need to do here? So first we need to find this very thing, this is our MPC. Okay, also you need to find out this very thing, which is our, here this is our B. Okay, demand for money is this 0.25 is actually our K, and this 5 is H. Okay, so just plug these values in this fiscal policy multiplier, you will get the value. I hope I make myself clear in this video. Okay, so if you really want to see how do we calculate the IS equation and LM equation, I will put the link into the info button and also into the description box. Hope you like this video. Thank you.